Assalamu alaikum everyone. This is the part 1 of O Levels Physics P1, October November 2020. Variant is 1 2 and the code for O Levels Physics is 5054. This paper is of 1 hour and you have 40 questions. In this part 1, we will only discuss 10 questions, first 10 questions of this paper. So let's get started. Question number 1. A heavy nail is fixed firmly to a wall. It is pulled by a string at 40 degree to the vertical. The nail does not move. The nail does not move. Three forces act on the nail: its weight, W, its tension, the tension in the string, the force are exerted by the wall. So there are these three forces. Okay, direction of one force is given here, the pull of the string. We'll be using the head to tail rule. According to this, the direction, you can see the direction of the force is upwards, means this is the head and this is the tail. So this head here will connect the tail of the other side. Let me draw it again. Now to determine its direction, you need to remember that this is its head and this is the tail. So this would be the head. The direction would be like this. And then this is the head and would be the tail. So this would be the head again. And this is the tail. So its direction would be like this. So downward direction, you can see that it would be weight. Let's look at the options. Option A, weight direction is going towards down, you can see in option A. And then the pull of the string is at this direction, like this. And then the R, force exerted by the wall, is in the direction towards the pull of the towards the tension of the in the string. So option A is correct for question number 1. Then let's move towards question number 2. Question number 2 says that a car begin to move its speed ups until it reaches a constant speed. It continues to travel at the constant speed for the rest of the journey. What happens to the acceleration and what happens to the velocity during the journey? So cars speeds up and then speeds up until it reaches a constant speed. So before it reaches a constant speed, its acceleration is changing, its velocity is changing. So option A is correct, that both acceleration and velocity are changing. Then let's move towards question number 3. So question number 3 is that the speed time graph is shown, during which part of the graph of the journey is the car moving with uniform, non-uniform acceleration. So you can see that in the C part, the car is moving with non-uniform acceleration as there is a curve. Option C is correct for question number 3. Then question number 4, a car is traveling towards a high speed, forwards at a high speed. At a high speed, the brakes are applied and the car skids along the road surface. In which direction and where does the friction force act? So a car is moving to forwards at a high speed and the brakes are applied and the car skids along the road surface. So in which direction the uh, friction force acts? So friction force always act in the direction of backward, means the car is moving forward. The car is moving forward. This is the direction of the car. So the friction force will act opposite to the direction of car. Means it will act backward. Because car is moving forward, so friction will act at backward and friction will act at the tires. So option A is correct for question number 4. Then let's move towards question number 5. Here it is. A car of mass 800 has a forward acceleration. Acceleration is 2.5 meter per second and mass is 800 kg. And a frictional force is 1200 Newton opposes the motion of the car. What is the driving force due to the engine of the car? So to find the force, the formula is F equals to ma. So m is the mass, A is the acceleration. So mass is 800 into 2.5. So it gives 2000. Then a force is given of 1200. So you need to add this frictional force to find the driving force. When this 1200 is added into 2000, it gives 3200, which is option B. So what you did, 800 into 2.5, the answer comes 2000 newtons. You add 1200, which gives 3200. Then let's move towards question number 6. A satellite orbits a planet in a circular path. So this question is regarding the circular path. Every year this question comes. It has a constant speed. There is a force on the planet due to the satellite. So there is a force on the planet due to the satellite. In which direction the force on is the force on the planet? So the force is always in the is perpendicular. So this is the satellite, this is the planet, and the force would be in this direction, which is B. So option B is correct for question number 6. Then question number 7. A block is hung on the spring balance. It is written, it's a spring balance. Now the marker inside the balance is pulled down by the block. What can be the position of the marker be used to determine? So what is the what can the position of the marker be used to determine? Let's read out the option. First option is the mass of the block in kg. Yes. The mass of the block in Newton. No. The moment caused by no. The weight of the block in kg. No. So weight is measured in Newton. Mass is in kg, and the spring balance isn't used to calculate the moment. So option A is correct for question number 7. Question number 8 says that there is an astronaut on a planet which has a gravitational field strength of 1/5 of Earth. So a spring 1/5 is the gravitational field strength of the Earth. So he hangs a sample of rock of the from a spring balance designed for use on Earth. Each sample has 0.1 kg. What you have to do is to 0. Now the spring reads balance reads 1 kg. How many samples of the rocks are there? Given that the spring balance read 1 kg, what you have to do is to 1.0 or directly 1 divided by 0.1. 1 divided by 0.1 gives 10. So 10 samples are needed on the Earth. Now it's given that the gravitational field on the planet is 1/5 of the value on the Earth. So to get these 10 pieces on that planet, you have to multiply it by 5. That is, as it is given that it is 1/5. So 10 into 5, which is 50. So this 50 is the same value on that planet. However, samples are 10 on the Earth. So option D is correct for question 8. Then question number 9. An electric charge plastic ball is at rest. Which type of field are caused by the ball? Okay, the ball is charged as well as it is at rest. So ball has mass and it is charged. So electric and gravitational field only. So B is the correct option. In question number 10, which list contains only quantities that can be changed by a force? Quantities that can be changed by a force. So shape can be changed by a force, velocity can be changed by a force, and volume can be changed by a force. So option D is correct for question number 10. I hope you understood it.